Hello everyone, I welcome you all in the C programming and data structures lecture. This is part 4 of application of stacks infix to postfix conversion. So without any further delay, let's get started. In this presentation, we will learn how to convert an infix expression to its equivalent postfix form using stack. That is, we will convert an infix expression to its equivalent postfix form with the help of a stack. So without any further delay, let's move on. Let's first get the idea behind how to convert an infix expression to its equivalent postfix form, right? Let's say we have the following infix expression. Let's say we have this infix expression 7 plus 5 into 3 divided by 5 to the power 1 plus 3 minus 2. 3 minus 2 is within parentheses, right? Now, how to use stack to convert the given infix expression to its equivalent postfix form? This is my question, of course. This is what we are dealing with. We want to use stack, right, for the purpose of conversion. But how to do this? Let's see this with the help of an algorithm. Actually, this algorithm will help us in converting an infix expression to its equivalent postfix form. And it is a very simple algorithm. We just have to follow all these steps one by one. And then we will also understand that why this algorithm works, right? First, we have to scan the symbols of the expressions from left to right. And for each symbol, we have to do the following. If the symbol is an operand, then print that symbol onto the screen. Simple. If symbol is an operand, then print that symbol onto the screen. Do nothing, just print that out. If symbol is a left parentheses, then put it onto the stack. If symbol is a right parentheses, then pop all the operators from the stack up to the first left parentheses and print them on the screen. Simple. We have to pop all the operators from the stack one by one and print them onto the screen until we encounter a left parentheses. Discard the left and right parentheses after that, right? If the symbol is an operator, this is very important, and if the precedence of the operators in the stack are greater than or equal to the current operator, then pop the operators out of stack and print them onto the screen and push the current operator onto the stack. Simple procedure. Otherwise, we'll push the current operator onto the stack. Fine? Now, let's evaluate this algorithm step by step. First, we'll go with this step. Scan the symbols of the expression from left to right. Okay, so this is what we have to do. So we are available with this expression 7 plus 5 into 3 divided by 5 to the power 1 plus 3 minus 2. Our task is to simply convert this expression to its equivalent postfix form, right? Here we have encountered this first symbol 7. Now what to do with this symbol? If symbol is an operand, then print that symbol onto the screen. Simply print that symbol onto the screen. So we'll print this symbol onto the screen. This is the output, right? So we will get 7 on the screen. After this, we have encountered this plus symbol. Now this is an operator, right? So if symbol is an operator and if the precedence of the operators in the stack are greater than or equal to the current operator, but currently there are no elements in the stack, right? So this condition will not satisfy, hence we'll come to this else part. We'll simply push this current operator onto the stack. Fine? We can see this over here, we have encountered plus, therefore we'll put this symbol onto the stack. That's it. This is our stack, right? And we'll simply push this symbol onto the stack. You might be getting the idea that how the algorithm is working, right? So if you have encountered an operator, you just simply push that operator onto the stack. Simple. Otherwise, you just simply print all the symbols onto the screen. Here you can see that whenever we have encountered an operand, we'll simply print that operand onto the screen, right? As you can see this, with 7, we are not doing anything. We just simply print that onto the screen. But whenever you encounter an operator, the main algorithm starts working. We have to push this operator onto the stack, especially when the stack is empty, right? Let's see the next symbol. Next symbol is 5. This means we will print 5 onto the screen, right? After this, we have star. Now what to do with this operator? According to the algorithm, if symbol is an operator and if the precedence of the operators in the stack are greater than or equal to the current operator, understand this. We have to compare the precedence of the operator onto the stack and the precedence of the current operator. Fine? We have to compare their precedences. Now, if the precedence of the operators, this means we have to compare the current operator with all the operators of the stack. Fine? If the precedence of the operators in the stack are greater than or equal to the current operator, then pop the operators out of the stack and print them onto the screen. Got it? So we have to pop the operators out of the stack in that case, right? And finally, we have to push the current operator onto the stack. Currently, you can see this, there is just one operator in the stack, right? We have to compare these two operators, right? Star and plus. You can see this, that star has greater precedence. Isn't that so? Star is obviously having a greater precedence or priority than plus. Therefore, we can simply push this symbol onto the stack. There's no problem in that because this condition is not satisfied. You can see this, according to the condition, we are checking if the precedence of the operators in the stack are greater than or equal to the current operator. But this is not the case. The precedence of the operator in the stack, which is plus, is actually having the less precedence than the current operator, which is star, which is multiplication operator, right? Therefore, this condition is not satisfied. Hence, we will land at this point, that is else part. And according to this else part, we'll push the current operator onto the stack. Simple. So let's push this operator onto the stack. That's it. This is the requirement. We must always understand this, that we have to compare the precedence of the current operator with all the operators of the stack, and we have to perform the operations accordingly, right? Now later, we have encountered this symbol, that is 3. Obviously, we'll simply print that onto the screen, right? This is what we have to do. After this, we have a divide symbol. Now what to do with this? Actually, we have a division symbol over here and we have a multiplication symbol over here. We know that the precedence of these two operators are same. This time the condition is satisfied if the precedence of the operators in the stack are greater than or equal to. Okay, so it's not just about that greater than. We have to deal with equal to as well. That means we have to deal with the precedences which are equal. Here, the precedence of the operator in the stack is equal to the precedence of the current operator, right? Therefore, we will pop the operator out of the stack, right? And print that operator onto the screen. And then after this, we'll push the current operator onto the stack. We'll do this after checking the precedence of the current operator with all the operators of the stack. Fine. Currently, we have 2 operators in the stack. First, we'll check the precedence of these 2 operators. We know that they are equal. We know that the precedence of these 2 operators are equal. Therefore, we can pop this operator out of the stack and then we'll print this operator onto the screen. Simple. After this, we will compare the precedence of these 2 operators and perform the same thing. Here you can see that the precedence of this operator is greater than the precedence of this operator. Therefore, we'll simply push this operator onto the stack. Else part will get evaluated, right? So this is how we should deal with all these things, right? Now I think it is making sense. If at all it is the case that the precedence of the current operator is equal to the operator onto the stack, we'll pop that operator out of the stack and then after this we'll print that operator onto the screen. In this case, we have printed star onto the screen, as you can see this over here. If it is not the case, then we will simply push the current operator onto the stack. Fine. Now this is the next symbol. You can see this is an operand, hence we'll simply print that onto the screen. After this, we have encountered this power operator. Now what to do with this? You can see this, that power operator is obviously having the highest precedence among all the operators, right? So definitely we can simply push this operator onto the stack, right? Now after this, we have this operand, we'll simply print that onto the screen. Then we have plus. Now, plus has the least precedence. We have a power operator onto the stack. Here we will compare these two. And you can see the precedence of this operator is actually less than the precedence of this operator. Therefore, it is very clear that we have to pop this operator out of the stack. Isn't that so? And then we have to print this onto the screen. Next, we will compare the precedence of this operator with this operator. Please remember, we have to compare the precedence of the current operator with all the operators onto the stack. Fine. Here you can see this, that plus is having least precedence and definitely this division symbol will get out of the stack, right? And then it will also get printed onto the screen, right? After this, we have plus and plus. They both have same precedence. This operator will get popped out of the stack and it will simply be printed onto the screen. Then we will push this operator onto the stack. Simple. I hope the idea is clear. Now we have a left parenthesis. What to do with this left parenthesis? Always push the left parenthesis on the stack. Simple. Here in the algorithm also it is given. If symbol is a left parenthesis, then push it on the stack. Here we'll simply push this onto the stack. After this, we have an operand. We'll print this operand onto the screen. Then we have minus, the subtraction operator. Understand this, that the left parenthesis has the least precedence among all. Therefore, we can push this symbol onto the stack. Fine. Then after this, we have 2, which is again an operand. So we'll print this onto the screen. Then we have a right parenthesis. Now what to do with this? According to the algorithm, if the symbol is a right parenthesis, then pop all the operators from the stack up to the first left parenthesis and print them on the screen. Simple. So we have to pop all the operators until we encounter the left parentheses. Here you can see we have encountered a subtraction operator, that is minus. So we'll simply pop this operator out of the stack and we'll print that onto the screen. After this, we have encountered a left parentheses. Therefore, we'll stop, and according to the algorithm, we'll discard the left and right parentheses, right? So we'll discard this left parentheses. Okay, discarding means simply popping this out of the stack. Now, whatever the operators you're left with in the stack, we will simply pop them out of the stack and print them onto the screen. Simple, right? So this is the required expression: 753 star 51 power divide plus 32 minus plus, right? This is the required expression. This is the equivalent postfix expression of this expression, right? And this is the complete algorithm, and we must always remember this algorithm. Now here is one homework problem for you. Use the algorithm mentioned in the lecture to find the equivalent postfix expression for the following infix expression. You can check your answer with the homework problem of the previous lecture. In the previous lecture, I gave you one homework problem where you have evaluated a postfix expression. That postfix expression is equivalent to this infix expression. So actually that postfix expression is the postfix form of this infix expression. The postfix expression obtained from the above infix expression must be equal to the postfix expression of the homework problem of the previous lecture. Okay friends, this is it for now. Thank you for watching this presentation.